Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. I will be presenting this morning a long video format. Uh, I shall continue my long video format topics. And for this morning, I will be discussing a random topic on long video format. And this is a long video format topic on trigonometry. Okay, let's proceed. As always, we got a problem. Okay, the given problem is this is a long video topic on trigonometry. So for those of you who are trying to take up engineering or want to familiarize yourselves with trigonometry, this is for you guys. The given problem is cosine of the quantity 30 degrees plus x close quantity, and this should be equal to 1 over the square root 2. The problem is asking, excuse me, what will be the value of x? Okay, let's try to bring out the solution. If we try to inspect the given equation is actually, it's an equation, but it's not algebraic, it is trigonometric, because there is the cosine function here. Without this cosine thing, it could be algebraic, but since there is the cosine function here, it's trigonometric. Okay, let's try to bring out the value of x. Solution. We rewrite the given trigonometric equation, and this is under one quantity, right? 30 degrees plus x. So to bring out the expansion of this one, we must have to bring out the expansion of this one. That's the key to the solution of the problem. So to bring out the expansion of this one, this falls under the so-called, it will be of the form cosine of quantity a plus b. Right? We must have to bring out the expansion of this one. This will be cosine. This is sine, right? Under the cosine function, if this is plus, this should be minus. Okay? The first function will be a, second function will be b, first function will be a, this is second function will be b. Meaning a first angle, second angle, first angle, second angle. So for a cosine function, it will be cosine, sine, and if this is plus, this should be minus. So we will be following this one. Okay, it involves our knowledge on the expansion of the cosine of two angles. Like what I said, cosine, sine, first angle, second angle, first angle, second angle, and since this is plus, this should be minus. Okay, and this should be equal to, if we try to simplify 1 over square root of 2, that will be 0.707. Okay. For cosine of 30 degrees, cosine of 30 degrees will be 0.866 times cosine of x. This is minus. Sine of 30 degrees, we could determine that one by using our calculator or by using our knowledge. So, because sine of 30 is actually 0.5, so this should be 0.5 times sine of x, and this should be equal to 0.707. Okay? This will be the resulting equation now. But what will I do is that I will try to transpose this 0.5 sine of x to the right. So I will be placing the equality sign here. This is a plus now. Okay, this is a plus. So I prepare that the left hand side will just be simply a pure cosine function, and the right hand side will be a sine function plus this constant here. Squaring both sides. Okay. we try to square both sides. Okay, 0.866 raised to the second power will be 0.75. Cosine of x raised to the second power will be cosine square of x, and this should be equal to. For the right hand side, it's an expansion of a binomial that involves a trigo function. So it will be the square of the first one. The square of the first one will be 0.25 sine square of x. The middle term will be the product of the first and the second times 2. So 0.5 times 0.707 times 2, that will be still a 0.707, okay, times sine of x. The last term on the right hand side will be the square of 0.707, and if you try to square 0.707, that will be 0.5. Okay, for the left hand side, since this is a cosine square function, the right hand side involves sine square function and simply sine function plus a constant. I would like to replace this cosine square of x by its equivalent. That is sine square of x plus cosine square of x is equal to 1. So if we try to take the equivalent of cosine square of x, cosine square of x should be equal to 1 minus sine square of x. Okay? So I will replace cosine square of x by 1 minus sine square of x. So this will now be 0.75 times the equivalent of this in terms of sine square, which is 1 minus sine square of x. Okay? This one I will transpose now to the left, so this will now be negative 0.25 sine square of x. This one I will transpose it to the left, so this will now be negative 0.707 sine of x. This one I will transpose it to the left, it will be negative 0.5. So what remains on the right hand side will be just simply 0. Then try to combine similar terms. Okay? Try to combine. After the combination, what will come out will be sine square of x minus 0.707x plus 0.5, and this should be equal to 0. And multiplying all terms by negative 1. So negative sine square of x times negative 1, this will now be positive. Negative 0.707, sorry for this one, there should be a sine of x here. Right? 0.707 times sine of x. Okay? So negative and negative, this will now be plus. Oh, this is 0.707 sine of x. Sorry for that one. Okay? This 0.25 times negative 1 will be negative 0.25, and this should be equal to 0. So it seems we are given now sine square of x plus 0.707 sine of x minus 0.25, and this should be equal to 0. So after the simplification, what comes out is actually a quadratic equation that involves a trigonometric function. So we will be using, this is normally, we always refer this as x squared on the original algebraic, and this is x and this is plus if you are constant. But for the meantime, it's not x squared, it is sine square of x. Okay? So we will be using the quadratic formula, in which the value of a will be equal to 1, b equal to 0.707, and the value of c equal to negative 0.25. Okay? So we could compute for the value of sine of x now. Sine of x will be by using the quadratic formula. This is negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we try to put values, sine of x will be equal to this value here. There are two values of x, or sine of x. If we try to use the positive one, sine of x with the subscript 1, meaning the first value of sine of x will be 0.2585. Okay, and to solve for x1, take the inverse of both sides, inverse sine. So x1 now will be arc sine of the right hand side, 0.2585, and what will come out will be 15 degrees. That is by using the positive sign from the quadratic formula. Sine of x with the subscript 2, meaning the second value of sine of x. If we try to use the negative sign, this will become negative 0.707, negative 1.224. That's something else, right? So it's more than 1. Divided by 2, it will be 0.9655, negative. So x2 now will be the arc sine of negative 0.9655. And the second value of x will be 75 degrees. Okay, so the answers here are actually 15 degrees, and the second value is negative 75 degrees. And if we try to check the validity of this one, just substitute 15 degrees here. We'll try to substitute. If this is 15 degrees, the total value of the angle inside will be 30 plus 15, that will be 45, right? And the cosine of 45 is actually 0.707. It is this one. Okay? This is one. And if we try to use the value of x to be negative 75, okay, 30 minus 75 will be, it will become cosine of negative 45 degrees. And this is still 8.707. So that's how we check the validity of our answers. So the correct value of x here is x will be equal to 15 degrees, and the second value will be negative 75 degrees. Okay, good morning from Los Angeles. This is Professor David.